Hey, this is Mr. Lowry. I just wanted to give you some help getting started on this domain and range of graphs worksheet in case you missed today's lesson. This is the homework for the lesson on November 11th, which was a Wednesday. That's for Cohort A. If you're in Cohort B, this assignment comes after the lesson on November 12th, which is on a Thursday. This is about domain and range of graphs and kind of builds a little bit on what we talked about in class. In class, we did this activity, which was about domain and range from word problems. So if you missed class today, go back in Canvas and find this assignment and work through it. There's a video to help you do that. It's going to be important to know for things like tests and quizzes. You're going to want to be able to know how to do domain and range from a real-world situation. This assignment, homework assignment, is a little bit more straightforward because you don't have to infer as much from the word problem. All of these functions here, or all these relations, excuse me, some of these aren't functions. All of these relations are continuous, which means that we can represent our domain and range with interval notation. So I'm going to make myself a little note that I'm going to use interval notation. Okay, we need to know what domain and range are, and we talked about those in class last week when we introduced those ideas. But just as a reminder, domain is all the possible input values, and range is all the possible output values. In this case, we're talking about x's for the domain and y's for the range. Okay, depending on what type of function or relation we have, whether our function or relation is discrete or continuous, that will determine what kind of notation we use. So for continuous functions and continuous relations, we use interval notation. The domain, let's start with number one here. The domain here is all the possible x values. We're going to use interval notation, and we're going to go from the lowest value to the highest value. So when we look at the x values here, these are all the x values, we want to look for the lowest one first. Okay, so it looks like we're never going to get lower than -1, right? Let me zoom in a little bit for you. Okay, we're never going to get lower than here. You might notice that there's an open dot here, and this open dot means that this point for -1, 4, is not part of the graph, but it goes all the way up to that point, really, really close. Okay, so what I would say here is that I want to go from -1 all the way up to 5. My highest value that I'm going to have, my highest x value is going to be 5. Since I have an open dot here, I don't want to include -1 as part of my domain. So by putting a parenthesis right here, what that means is go as close as possible to -1, but exclude -1 itself. When you look at the graph here, you'll notice that 0 is not the lowest x value. You got all this stuff in between 0 and -1. So like -0.5 and -0.8 and -0.9999. Those are all part of the domain. We want to include those. We just don't want to include -1. All right, on the other side, we have this like square looking thing. All that means is an endpoint, and it's a closed dot endpoint. So a square or a closed dot, it's the same kind of thing. It's filled in. What that means is that point, 5, 0, is actually part of our graph, which means we can include 5 in our domain, and we do that with a square bracket. So this notation means your domain, your x values, start at really, really close to -1 and go all the way up to 5, including 5, and everything in between counts, including decimals and fractions. So like 1.1 or 2.05 or 4.999, those all are included in our domain here. And we're talking about input values or x's. Okay, for the range, we're talking about the outputs or the y values. What are all the possible output values for this function or relation? So we want to, again, start with the lowest value. This is where our graph is the lowest. Okay, now there's a 5 right there, but be careful, that's an x value. We're talking about y values. How high is this guy? So here's -1, here's 0, here's 1, here's 2. We're down here at 0. Our lowest point on the graph, our lowest y value, is going to be 0. And since, again, that's a closed dot, we're going to put a bracket around 0 to say, hey, we want to include 0. On the top end, we got this guy. up here. So it looks like we're going almost all the way to 4. We're never going to get higher than 4 for sure, but we also have this open dot, which means we're getting pretty close to 4 without actually touching 4. So we put 4 here as our boundary, and then we put parenthesis here that means go all the way up to 4, but exclude 4 itself. So 3 is part of the range, and 3.1 is part of the range, and 3.5 is part of the range, and 3.9 and 3.9999, and as close as you can get to 4 without actually including 4. All those are included in the range here. I think I said domain, sorry. 3 is part of your range, 3.1 is part of your range, 3.999 is part of your range. So all the way up here. We're talking about y values or range. So basically how you're going to do this is you're going to look at x's for the domain and y's for the range. You want the lowest value on the left, and you want the highest value on the right. So here's my lowest x, here's my lowest y, here's my highest x, here's my highest y. Okay, and then you got to figure out, do you include that endpoint or not? All right, so for open dots, we're going to exclude, which means we're going to use one of these guys. Okay, for closed dots, we want to include that in our domain or range, which means we're going to use a bracket. Okay, maybe not both, but if that point is included, we use one of those two symbols. All right, now to show if a function, a relation is a function, we're going to use the vertical line test. Okay, what we're looking for is we want the vertical lines that we draw to only hit the graph once. So if you think about it, if you draw any vertical line through this graph, it's only ever going to hit the graph one time. Okay, if the vertical lines that you draw hit the graph more than once, then it's not going to be a function. In this case, we're good because every vertical line we draw will only ever hit the graph one point. So we're going to say, yes, it is a function. Okay, that's just kind of a quick review on function notation for this assignment. And in the next video, I'll go through number 8 down here, which is a little bit trickier.